March 15, 1945, 7:23 a.m. Iwo Jima Volcano Islands. Captain Tadashi Nakamura crouched in his cave fortification on Mount Suribachi's northern slope, watching through his periscope as American engineers worked on the captured Japanese airfield below. The airfield, Motoyama Airfield No. 1, had taken Japanese military engineers 8 months to construct using thousands of forced laborers and careful planning. The Americans had captured it 6 days ago. Nakamura expected them to spend weeks, perhaps months, repairing the damage Japanese demolitions had inflicted. Instead, he was witnessing something his military engineering training said was impossible. Hundreds of American engineers swarmed across the airfield like ants. Massive machines he'd never seen before. Bulldozers larger than Japanese tanks, graders that moved tons of earth per minute, rollers that compacted runways in single passes, operated continuously. At night, portable electric lights illuminated the work site, turning darkness into day. The noise was constant, engines roaring, equipment clanging, organized chaos that violated every principle of Japanese military construction doctrine. "They're wasting effort," Nakamura muttered to his aide. "Building airfield requires careful surveying, precise grading, proper drainage systems, adequate time for soil compaction. These Americans are rushing, cutting corners, building airfield that will fail in first heavy rain. This is typical American impatience, speed over quality, quantity over precision." His engineering assessment was based on Japanese military construction standards developed over decades. Japanese airfield construction emphasized permanence, careful planning, and quality that would last years. What Nakamura was observing violated all those principles. But what stunned him into silence later that morning was the sight of a C-47 transport aircraft landing on the partially completed runway. 6 days after capture, with construction still ongoing, with equipment still operating on adjacent sections, American aircraft were already using the airfield. "Impossible," Nakamura whispered. "That runway cannot support aircraft. The soil compaction is inadequate. The surface is rough. The drainage is incomplete. That aircraft should sink or crash. This violates everything I know about airfield engineering." The C-47 landed smoothly, taxied to a parking area, unloaded casualties for medical evacuation, and took off again. It was followed by another. Then another. Within hours, dozens of aircraft were operating from an airfield Japanese engineers had said couldn't function for weeks. What Captain Nakamura didn't know, what Japanese military intelligence had completely failed to understand, was that he was witnessing the Seabees at work. The US Navy construction battalions, whose motto "Can Do," and unofficial motto "The difficult we do immediately," "The impossible takes a little longer," would revolutionize military engineering in the Pacific. Within 7 days of capturing Motoyama No. 1, American engineers would have it operating at full capacity. Within 2 weeks, they'd extend it. Within a month, they'd build 2 more complete airfields on Iwo Jima from scratch. Accomplishments Japanese military doctrine said required 6 months minimum. This is the story of how American engineering speed shattered Japanese tactical planning, how industrial methods defeated careful craftsmanship, and how Japanese soldiers' stunned disbelief turned to demoralization as airfields appeared overnight where Japanese doctrine said they couldn't exist. To understand why Japanese soldiers were stunned by American engineering speed, you need to understand Japanese military construction philosophy, a tradition emphasizing careful planning, quality construction, and permanent results. Japanese military engineering reflected broader cultural values, careful planning over rapid execution. Japanese engineers surveyed sites meticulously, studied soil conditions extensively, and designed with long-term durability as the primary goal. Rushing construction was considered unprofessional. Quality over speed. Japanese military construction standards required precise grading, proper drainage, and adequate compaction time. Corners weren't cut, and standards weren't compromised. The result was construction that lasted but took considerable time. Manual labor over mechanization. Japanese engineering relied heavily on human labor, soldiers, conscripts, and forced workers performing tasks by hand. Limited mechanization meant slower progress but careful control. Permanence over expedience. Japanese airfields were built to last years. Runways were designed for heavy bombers, Facilities were constructed with peacetime standards. The philosophy was build it right once rather than build it fast and improve it later. This philosophy worked well when Japan controlled territory and had time to develop infrastructure. On islands Japan had held for years, airfields were impressively built. Proper drainage, concrete runways, extensive facilities. But this approach had a critical weakness: it was slow. Japanese military engineering required months to build airfields that operational necessity demanded in weeks or days. Major Yoshio Kodama, a Japanese military engineer who helped construct airfields across Pacific Islands before the war, described the Japanese approach. "We built airfields to standards that would be acceptable in peacetime Japan. Proper surveys taking weeks, careful grading taking months, soil testing and compaction requiring patience. The result was airfields of which we could be proud, well-drained, properly constructed, capable of lasting years. But they took 6 to 8 months to build, even with thousands of laborers. We considered this acceptable because quality requires time. This quality requires time philosophy was about to collide with American speed as quality, engineering that would shatter every Japanese assumption about what was possible in military construction. The US Navy construction battalions, nicknamed Seabees from the initials CB, represented a fundamental departure from traditional military engineering. Created in 1942, the Seabees were organized as military units but recruited from civilian construction workers, carpenters, heavy equipment operators, engineers, electricians. They brought civilian construction industry methods to military engineering, creating an organization unlike anything in Japanese or even traditional US military structure. CB organizational principles. Speed as primary metric. CB construction doctrine prioritized getting facilities operational quickly. Quality was good enough for purpose rather than perfect for permanence. If an airfield worked, it was adequate. Improvements could come later. Mechanization at maximum scale. Seabees operated with equipment ratios unprecedented in military organizations. Heavy equipment per man was 10 to 1 compared to Japanese engineering units. Every task was mechanized if possible. 24-hour operations. CB construction sites operated continuously with rotating shifts. Work never stopped. Portable lighting turned night into day. This continuous operation compressed timelines Japanese engineers considered fixed. Standardized methods. Seabees used standardized construction techniques, refined through repetition. They would build hundreds of airfields using the same methods, achieving efficiency through practice that Japanese engineers building single airfields couldn't match. Improvisation as doctrine. CB training emphasized adapting to circumstances rather than following rigid plans. If standard methods didn't work, CBs improvised. This flexibility allowed them to solve problems that would paralyze more rigid engineering organizations. The equipment CBs operated shocked Japanese observers. CB heavy equipment, typical battalion, bulldozers, D7 and D8, 60-plus machines, motor graders, 20-plus, scrapers, 30-plus, rollers compaction, 15-plus, dump trucks, 50-plus, cranes, 10-plus, portable electric generators, 20-plus, concrete mixers, 25-plus, asphalt plants, mobile units, water pumps, 40-plus. This equipment concentration meant a single CB battalion could move more earth in one day than an entire Japanese engineering regiment could move in a month, using manual labor and limited mechanization. But equipment alone doesn't explain CB's success. The real revolution was doctrinal. The decision that good enough to work now was better than perfect in 3 months. Commander John J. Perry, a CB officer who supervised dozens of Pacific airfield constructions, explained the philosophy. Japanese engineers built airfields that would last 10 years. We built airfields that would work in 10 days. If they lasted 10 years, great. If they only lasted 1 year but served their purpose immediately, that was also acceptable. War doesn't wait for perfect construction. Adequate airfields available immediately win battles. Perfect airfields available eventually don't. That's the fundamental difference between our approach and the Japanese approach. The Pacific Island campaigns provided stage for CB engineering to demonstrate capabilities Japanese military deemed impossible. Guadalcanal, August 1942. Japanese engineers had spent months building Henderson Field before American invasion. Seabees captured it damaged, repaired it in 72 hours, and had Marine aircraft operating while Japanese forces still controlled parts of the island. Bougainville and November 1943, Seabees landed with assault troops and began airfield construction while combat was ongoing. First aircraft landed 16 days after initial landing. Japanese intelligence had predicted minimum 60 days. Los Negros, February 1944. Seabees began airfield construction on captured Japanese airstrip while Japanese forces counterattacked. Worked under fire, had operational airfield in 8 days, supporting further operations. These demonstrations created pattern. Seabees built functional airfields in 10 to 20 days, where Japanese military doctrine said 120 to 180 days minimum was required. This speed compression had strategic implications. American forces could establish air superiority within days of capturing territory, preventing Japanese reinforcement and enabling further advances. But Japanese military observers initially dismissed these achievements as flukes or exaggerations. Japanese intelligence reports from 1943 suggested American engineering speed was propaganda, that reported construction times were impossible, that Americans must have been building to inadequate standards. This dismissal would prove catastrophically wrong, as American island-hopping campaign accelerated and Seabee construction speed became decisive operational advantage. The Battle of Iwo Jima provided definitive demonstration of Seabee engineering capabilities under worst possible conditions. Iwo Jima's terrain was nightmarish for construction: volcanic ash soil that shifted and compacted poorly, steep slopes, limited flat ground, underground steam vents, and constant Japanese artillery fire from positions that overlooked construction sites. Japanese engineers had built 3 airfields on Iwo Jima over 2 years, using thousands of forced Korean and Japanese laborers. They'd struggled with the difficult terrain, poor soil, and limited equipment. The result was adequate airfields, but construction had been slow and difficult. American invasion plan required rapid airfield repair and expansion to support strategic bombing campaign against Japan. B-29 bombers damaged over Japan needed emergency landing fields. Fighter escorts needed bases closer to Japan. The operational requirement was urgent: get Iwo Jima airfields operational immediately. The Seabees delivered beyond anyone's expectations. Iwo Jima airfield construction timeline: Motoyama No. 1. Captured March 9, 1945, D+18. First aircraft landed March 15, 1945, 6 days after capture. Operational for emergencies March 16, 1945, 7 days after capture. Extended 1,000 feet March 26, 1945, 17 days after capture. Full operational capacity April 2, 1945, 24 days after capture. Motoyama No. 2. Captured March 11, 1945, D+20. Repair began March 12, 1945. First aircraft landed March 21, 1945, 10 days after capture. Operational March 29, 1945, 18 days after capture. Motoyama No. 3. Construction started from scratch March 20th, 1945. Basic strip completed April 15th, 1945, 26 days. Full operational May 10th, 1945, 51 days. These timelines shocked Japanese observers who'd calculated that American engineering would require months to make captured airfields operational. Captain Nakamura, watching from his cave, recorded his observations. March 16, 1945. American aircraft now landing regularly on Motoyama No. 1. This is impossible by any engineering standard, I understand. The soil is volcanic ash. It should require months to compact adequately. The drainage is incomplete. First rain should flood the runway. The surface is rough. Aircraft should suffer landing gear damage. Yet they land. They take off. They operate continuously. Either Americans have developed construction techniques we don't understand, or they're accepting risks we would never accept. Either way, they've achieved in 1 week what took us 8 months. What Nakamura didn't understand was that Seabees weren't trying to build permanent airfields to peacetime standards. They were building expedient airfields that would function adequately for immediate operational needs. The difference in philosophy created 10-to-1 difference in construction speed. Japanese prisoners captured during the Iwo Jima campaign were held near Seabee construction sites. What they witnessed contradicted everything they'd been taught about military engineering. Corporal Yuki Tanaka, captured March 12th and held in a POW camp adjacent to Motoyama No. 1, described observations in post-war interviews. I watched American engineers work for 2 weeks before being transported to the main POW camp. What I saw was unlike any military construction I'd witnessed. First, the machines. They had hundreds of machines, all enormous, all operating constantly. Their bulldozers moved more earth in 1 hour than 100 Japanese soldiers could move in a day with hand tools. Second, the organization. They worked in shifts. Day shift, night shift. Construction never stopped. At night, they had portable electric lights, making it bright as day. Third, the speed. They didn't survey carefully. They didn't test soil extensively. They didn't follow proper procedures. They just built fast. And somehow, it worked. The specific techniques Seabees used at Iwo Jima illustrated their engineering philosophy: soil stabilization. Rather than waiting months for volcanic ash to compact naturally, Seabees used mechanical compaction, heavy rollers making dozens of passes, achieving in hours what would take months naturally. They also mixed coral and crushed rock into ash to improve stability. Pierced steel planking, PSP, for surfaces that couldn't be adequately compacted. Seabees laid interlocking steel mats that distributed aircraft weight. PSP could be installed in hours and provided immediate usable runway surface. Coral mining. Seabees identified coral deposits on the island, blasted them loose with explosives, crushed the coral with portable crushers, and spread it as runway-based material, all in continuous operation that compressed months of Japanese quarrying into days. Drainage improvisation. Rather than designing elaborate drainage systems requiring extensive excavation, Seabees used rapid installation culverts and surface grading that moved water adequately, if not perfectly. 24-hour shifts. Multiple Seabee battalions worked simultaneously. One battalion on Motoyama number 1, another on number 2, a third starting number 3. Within each site, 3 shifts rotated, ensuring construction never stopped. The result was airfields built to adequate rather than perfect standards, in timeframes Japanese engineering doctrine said were impossible. The speed of Seabee airfield construction had immediate strategic consequences that validated the good enough fast philosophy over the perfect slowly approach. B-29 emergency landings. The primary strategic justification for capturing Iwo Jima was providing an emergency landing field for damaged B-29 bombers returning from Japan. The first emergency landing occurred March 4, 1945, while the battle was still raging. By war's end, over 2,400 B-29 emergency landings had occurred on Iwo Jima, saving approximately 24,000 aircrew lives. These emergency landings couldn't have waited months for perfect airfield construction. Damaged bombers needed immediate landing facilities. Seabee speed saved lives Japanese engineering timelines would have lost. Fighter escort operations. P-51 Mustang fighters began operating from Iwo Jima in March 1945, providing long-range escort for B-29 raids on Japan. This capability was only possible because Seabees had airfields operational immediately. Japanese defense planners had calculated that American capture of Iwo Jima wouldn't affect the strategic bombing campaign for 3 to 4 months, time they believed Americans would need to construct operational airfields. Instead, impact was immediate because airfields were operational within days. Psychological impact on Japanese forces. Watching American engineers build airfields in days that had taken Japanese engineers months demoralized Japanese defenders. It demonstrated American material superiority in tangible, undeniable way. Lieutenant Akira Sato, a Japanese artillery officer on Iwo Jima, wrote in his final letter before death, "We watch Americans build airfields as easily as children build sand castles. They have machines we've never seen, techniques we don't understand, and speed we can't comprehend. They captured our airfield and had it operational before we finished destroying documents. They're building new airfield in weeks that would take us a year. This engineering capability demonstrates why we're losing. Americans can build faster than we can destroy. This realization is more demoralizing than combat itself." The Okinawa campaign, April to June 1945, provided the final demonstration of Seabee engineering dominance under the worst possible conditions: hostile fire, difficult terrain, and operational urgency. Okinawa had several Japanese-built airfields that American forces needed operational immediately to support the massive invasion force and the projected operations against Japan's home islands. Okinawa Airfield Reconstruction Achievements. Yontan Airfield. Captured April 1st, 1945. L-Day, first day of the invasion. Japanese demolitions, extensive craters, obstacles mined. Seabee repair began April 1st, 1945, same day as capture. First aircraft landed April 2nd, 1945, one day after capture. Full operations April 8th, 1945, 7 days after capture. Kadena Airfield, captured April 1st, 1945, L-Day. Damage moderate, some demolitions but largely intact. Seabees repair began April 1st, 1945. First aircraft landed April 2nd, 1945, one day after capture. Full operations April 6th, 1945, 5 days after capture. Iwo Jima Airfield. Island captured April 21st, 1945. Airfield captured April 21st, 1945. Repair began April 22nd, 1945. First aircraft landed April 29th, 1945, 8 days after capture. The speed was staggering. Seabees had aircraft operating from captured airfields faster than Japanese forces could evacuate them. In some cases, Seabees began repairs while Japanese soldiers still occupied parts of the airfield perimeter. Japanese Lieutenant Colonel Hiromichi Yahara, senior staff officer for the 32nd Army defending Okinawa, survived the battle and wrote a post-war assessment. American engineers' speed destroyed our defensive planning. We calculated that captured airfields would require 30 to 60 days repair before operational. This timeline guided our defensive dispositions. We positioned forces to interdict supply lines to captured airfields, assuming months before airfields threatened us. Instead, American aircraft operated from captured fields within days. Our defensive assumptions were invalidated immediately. American engineering capability was a weapon we had no counter for. You cannot defend against an enemy who establishes air superiority from your own airfields before you've completed retreating from them. Behind the statistics were Seabees working under conditions that tested human endurance and courage. Seabee construction crews at Iwo Jima worked under constant Japanese artillery fire. Mount Suribachi and northern positions overlooked construction sites. Japanese artillery targeted work crews continuously. Seabees took casualties while building airfields, killed by artillery fire, mortar rounds, and occasional Japanese infiltrators. Construction electrician 3rd Class James Miller died March 14, 1945, when Japanese artillery struck his bulldozer while grading Motoyama No. 1. He was 24 years old. Builder 1st Class Robert Thompson died March 18, 1945, defusing a Japanese mine left on the runway. He was 28 years old. The Seabees accepted these casualties as cost of maintaining construction speed. Work didn't stop when men were killed. Other operators climbed onto equipment and continued. The dead were buried, and construction continued because operational necessity demanded completed airfields regardless of cost. Steelworker 2nd Class Frank Eibach, working on Motoyama No. 2 during Iwo Jima campaign, described the experience in a 1987 interview. "We worked 12-hour shifts, 7 days a week. Japanese artillery fell randomly. You never knew when a shell would land. We lost men. We saw them die. Then we went back to work because B-29s needed places to land, and that mattered more than our fear. Were we heroes? Number. We were construction workers doing our jobs under fire. But we were damn proud that aircraft were landing on runways we'd built while bullets were still flying." The psychological strain was significant. Seabees weren't infantry trained for combat, they were construction workers in military uniform. Being under fire while operating bulldozers created stress their civilian training hadn't prepared them for. But Seabee units maintained morale through professionalism and pride in their work. They took satisfaction in accomplishing impossible tasks. The unofficial motto, "The difficult we do immediately, the impossible takes a little longer," captured their self-image. They were going to build those airfields no matter what. Late in the war, Japanese military attempted to replicate American engineering speed. The attempts failed, revealing why Seabee success wasn't replicable without an industrial base supporting it. Japanese military engineers studied captured American equipment and construction techniques. They understood American methods theoretically, but replication required equipment and materials Japan couldn't produce. Critical resources Japan lacked: heavy equipment, Japanese industry in 1945 was producing perhaps 50 bulldozers monthly versus American production of 2,000 plus monthly. Japanese military had hundreds of bulldozers total versus Americans operating thousands in the Pacific Theater alone. Fuel. Japanese fuel shortages meant equipment often sat idle even when available. Seabee operations consumed fuel lavishly, hundreds of gallons per machine per day. Japanese forces couldn't allocate fuel at such rates. Spare parts. American equipment came with extensive spare parts inventories. Broken machines were repaired quickly or cannibalized to keep others running. Japanese equipment broke down and stayed broken for lack of parts. Trained operators. Seabees recruited experienced civilian equipment operators. Japanese military had few trained operators and limited time to train new ones. American operators had years of civilian experience. Japanese operators had weeks of military training. Steel for mat. Pierced steel planking required hundreds of tons of steel per airfield. Japanese steel production was devoted to weapons. Americans produced PSP by the thousands of tons specifically for airfield construction. Japanese engineering units attempting to match Seabee speed failed consistently. Major Yoshio Kodama, attempting to build an emergency airfield on Kyushu in spring 1945, wrote in his diary, "I've studied American engineering methods. I understand their techniques, but I cannot replicate them. I have 20 bulldozers. Americans have 200. I have fuel for 2 hours daily operation. Americans operate 24 hours. I have soil compaction equipment that takes days. Americans have equipment that completes compaction in hours. I have untrained conscript labor. Americans have civilian construction professionals in uniform. Understanding American methods doesn't help when I lack resources to implement them. This is humiliating, knowing how to succeed but unable to execute because our industrial capacity can't support it." After the war, Seabee contributions were recognized but often overshadowed by combat operations. The public celebrated Marines who took islands, but understood less about engineers who built airfields that made island capture strategically valuable. Seabees built 111 major airfields and hundreds of smaller facilities across the Pacific. They constructed over 400 miles of roads, more than 700 buildings, and logistics infrastructure supporting the entire Pacific campaign. They did this under fire in hostile conditions, at speeds that redefined what was possible in military engineering. Japanese military officers studying American operations post-war consistently identified Seabee engineering as a critical American advantage. Admiral Suemu Toyota, Commander-in-Chief of the Combined Fleet in 1945, wrote in his post-war memoir, "American victory in the Pacific was inevitable given material superiority. But American engineering speed accelerated that victory considerably. Every island Americans captured became an operational base within days. We couldn't match this. We'd spend months building airfields Americans would capture and have operational before we'd finished evacuating. This engineering capability meant Americans could island hop faster than we could prepare defenses. American engineers were as important to victory as American combat forces." March 1995. Iwo Jima, 50-year anniversary of the battle. American and Japanese veterans gathered at sites of former airfields for a commemoration ceremony. Among them was former Seabee Frank Ibach, 73, and former Japanese Captain Tadashi Nakamura, 78. Through translators, they discussed the airfield construction that had shocked Nakamura 50 years earlier. Nakamura spoke first. "In March 1945, I watched from a cave as American engineers built an airfield in days that had taken us 8 months. I couldn't believe what I was seeing. Every principle of engineering I'd been taught said this was impossible. The soil wasn't adequately compacted. The drainage wasn't proper. The surface wasn't smooth enough. Yet aircraft landed safely. They operated continuously. I realized then that American engineering wasn't following our rules. You'd develop different rules that worked better for military operations." Former steelworker Ibach responded, "We weren't building airfields to last forever. We were building airfields to work immediately. If they lasted years, great. If they only lasted months but served their purpose, that was acceptable. War doesn't wait for perfect construction. We built good enough to work now rather than perfect eventually." That philosophy, speed over perfection, was revolutionary. but it required industrial capacity to provide equipment, materials, and train personnel. Without American industrial support, our methods wouldn't have worked. A younger attendee, grandson of a Japanese soldier killed on Iwo Jima, asked, "Could Japan have adopted American engineering methods?" Nakamura answered, "Theoretically, yes. Practically, number. American methods required resources we didn't have. Your grandfather's generation lost not because we were incompetent, but because we were fighting an enemy whose industrial capacity made impossible things possible. American engineers had equipment we'd never seen, materials we couldn't produce, and training we couldn't replicate. Understanding this doesn't diminish your grandfather's service. It explains why his sacrifice, brave as it was, couldn't prevent American victory." The ceremony concluded with both sides acknowledging that Seabee engineering had been a decisive factor in the Pacific victory, enabling the island-hopping strategy that brought the war to Japan's doorstep. Former Seabee Commander John Walsh delivered closing words. "Seabees were construction workers who became warriors. We fought with bulldozers instead of rifles, but we were under fire just like infantry. We built airfields so aircraft could save the lives of B-29 crews. We built roads so supplies could reach front lines. We built facilities that supported every operation in the Pacific. We did this fast because speed mattered. Perfect airfields available in 3 months don't win wars. Adequate airfields available in 3 days do. That was our contribution, making impossible construction possible through American industrial methods applied to military engineering. The Seabee engineering revolution permanently changed military construction doctrine. The principle that good enough fast beats perfect slowly in military operations became the foundation for modern military engineering worldwide. Final statistics. Seabee Pacific Theater accomplishments, 1942 to 1945. Major airfields built or rebuilt, 111. Minor airstrips built, 441. Roads constructed 5,000 plus miles. Buildings constructed, 700 plus major facilities. Bridges built, 400 plus. Fuel storage capacity installed, 100 million gallons. Seabees deployed, 325,000. Casualties, killed in action, 272. Units awarded Presidential Unit Citations, 33. Iwo Jima specific. Airfields operational. 3. Construction time, Motoyama No. 1 repair. 7 days to first aircraft, 24 days to full operational. B-29 emergency landings enabled, 2,400 plus. Aircrew lives saved, approximately 24,000. Japanese estimate of construction time required, 120 plus days. Comparative construction speeds. Average Seabee airfield construction, 15 to 30 days. Average Japanese airfield construction, 120 to 180 days. Speed advantage, 4 to 8 times faster. Strategic impact. Islands became operational bases immediately after capture. The story of Seabee engineering in World War II is ultimately about how industrial methods applied to military operations create overwhelming advantages, and how speed can matter more than quality when operational urgency demands immediate results. Japanese soldiers were stunned when US engineers built airfields in a week because Japanese military engineering doctrine said this was impossible. Japanese engineers built to peacetime standards requiring months. American engineers built to works now standards requiring days. Captain Nakamura had watched from his cave expecting American engineering to take months. Instead, he saw aircraft landing on the captured airfield within a week. Everything he'd been taught about proper engineering said this shouldn't work. But it did work because American engineering had a different definition of proper. Proper meant operationally adequate immediately, not theoretically perfect eventually. The philosophical difference created a 5 to 10 times speed advantage that had strategic consequences. American forces could establish air superiority within days of capturing territory. Japanese forces couldn't reinforce or counterattack effectively because American aircraft were already operating from captured bases before Japanese forces finished retreating from them. The Seabees accomplished this through a combination of factors Japanese military couldn't replicate. Industrial capacity, providing unlimited equipment and materials. Civilian expertise applied to military problems. Doctrine emphasizing speed over perfection. Willingness to accept good enough rather than insisting on perfect. Modern military engineering worldwide follows the principles Seabees pioneered. Speed matters. Adequate facilities available immediately beat perfect facilities available eventually. Construction standards should match operational requirements, not peacetime ideals. Industrial methods work better than artisanal methods for military engineering. Japanese soldiers were stunned by airfields appearing in days because their doctrine said months were required. They learned that doctrine reflecting industrial scarcity couldn't compete with doctrine reflecting industrial abundance. The lesson extended beyond engineering. In industrial warfare, the side with greater material resources can afford approaches that seem wasteful or inadequate by traditional standards but prove more effective because speed and scale matter more than efficiency and perfection. Seabees proved this lesson with bulldozers and determination. They built airfields in a week that stunned enemies who'd spent months building theirs. And those quickly built airfields served their purpose perfectly, providing immediate operational capability that contributed decisively to American victory. Japanese soldiers were stunned. American engineers just kept building. And the airfields that appeared overnight enabled aircraft that brought war to Japan's doorstep, proving that speed in military construction matters as much as speed in military operations. The stunned disbelief of Japanese observers became recognition of American material superiority that no amount of Japanese courage or tactical skill could overcome. The Seabees built, the aircraft landed, and American engineering speed became a weapon the Japanese military had no answer for.